Hello, my name is Joydeep Ghosh. I'm a professional physicist and founder of an educational startup called Owlyard. Welcome to our first course on Introduction to Algebra for high school students. I'm excited to help you learn the basics here step by step so that you can handle real world problems, standardized tests, or achieve any other related goals you may have. Just a heads up, whatever you learn here, it actually took humanity hundreds or even thousands of years to figure out. So it is totally understandable if some concepts seem a bit tricky to you at first. My goal is to help you get started on this exciting journey.
Okay, so regarding our course, we will actually cover the six introductory topics in the following order. So first, we will discuss sets. Second, we talk about functions or maps. Next, we discuss real numbers. And then we start talking about how to solve equations. So first, linear equations, and then quadratic equations, and finally we'll talk about complex numbers. So at the end of this course, the outcomes that we are looking forward to are the following. So first, you should be able to understand the concepts of sets. You can compute functions. You can work with numbers, or even you can work with numbers, or even analyze or apply their properties in various different mathematical scenarios. You should be able to solve equations, linear or quadratic. And finally, with some practice, you can turn a word problem into mathematical equation, and eventually you should be able to solve it. So these are the goals. Having said that, here is how our course works. Each topic is explained through some short videos with a quiz for each video to help you practice. You can go at your own speed, and everything is available anytime on Owlyard's course portal. Good. So let's get started. So as we mentioned that our first topic is set, right? So let's first think how we organize the objects around us. What do? We try to create collections, right? So we create playlists of musics we like, or albums of photos we love. So we create collection of similar objects to organize better. Now, Cantor, a German mathematician, um, first realized that mathematical concepts and logical objects can be collected too in a very similar fashion. And if done following some basic rules, such collections can become the fundamental building block of modern mathematics. You can literally view or process any mathematical operation using the properties of such collections. And such collections are actually called sets. So if somebody has to define what set is, we should say that set is simply a well-defined collection of distinct objects. So by the way, these objects are often referred to as members or elements of set. And there are two words to focus on here. One is well-defined and another one is called distinct. So what does well-defined means? Well-defined means that if I specify a set, then there should be a very easy way to determine if an element belongs to that set or not. So for example, if I say that there exists a set for all the vowels in the English alphabets, then we clearly know that A is a member of that set, A being a vowel, and C, for example, not being a vowel, is not a member of that set, right? So that's what well-defined means. And distinct means there is no duplication allowed. Um, any member only appear once in a set. So these are the basic rules that we are talking about, and these are the rules that actually distinguish a set from just any collection, right? Good. Now we actually want to go over some examples, but in order to write the examples, I need to adopt a notation. Now, there are two notations that are used widely in order to represent sets textually. We'll talk about the visual representation later. So the first one is called the roster method or roster notation, and the second one is called the set builder notation or set builder method. So let's say that I have a set called A. Let's denote it like that. By the way, always remember that we usually denote any set with a capital letter in the alphabet. Okay. So A, and if we say that A is a set that contains all the natural numbers starting from 1 and ending at 5, then roster method says you start with a curly bracket in order to represent that set and literally specify all the members that belong to that set. So 1, 2, 3, 4, 5. So that's what the roster method is. Now in the set builder notation, if you try to represent it in the similar fashion, then the way you do it is A, you start the curly bracket, you take an algebraic notation, algebraic symbol, for example, n, and specify the condition on that symbol. So the condition on that symbol is n is a natural number greater than equal to 1 and less than equal to 5. So in the set builder notation, we don't have to literally specify each and every member, but you take a symbol and then you apply the condition on the symbol. So clearly you can see that roster method is very readable, user-friendly probably, but there is a problem. There are some sets which has infinite number of elements. And then it is inconvenient or impossible to express it in the roster notation because you cannot write infinite numbers or infinite elements, right? Set builder notation actually allows you to do that because you are just specifying the constant, the constraint on that. And we will discuss these things in details when we discuss the examples. Okay, so that's all for today. And this is your introduction to sets. So what we have covered is what sets are and how to represent them. Summarizing, sets are distinct collection of well-defined objects. This definition is very simple, but they are incredibly powerful to describe the world of mathematics as we will see. Okay, thank you for watching. Don't forget to work on the quiz to get a better grasp of the concepts, and see you in the next video. Thank you.